What would you do if you were given this sequence on the exam and were asked to identify whether this sequence is an arithmetic sequence or a geometric sequence? Now, we notice that there is a difference between the values of -2. That is, 100 take away 2 is 98. 98 take away 2 is 96. 96 take away 2 is 94. Therefore, we have a common difference of -2. This means that this sequence is an arithmetic sequence. An arithmetic sequence is a sequence that is associated with a common difference between the values, which is supported by this formula. an equals a1 plus n take away 1 multiplied by d. You need to be aware of this formula for the exam. Let's confirm that this sequence is indeed an arithmetic one using the formula. Now, a1 is 100 because it's the first value. a2 is 98, which is the second value, and a3 is 96. Let's use the formula to find 96 as the third value, meaning a3 equals a1, which is 100, plus 3 take away 1 multiplied by -2, which is a common difference that we found. If we plug that onto the calculator, we will get 96. Therefore, we have confirmed that this sequence is indeed an arithmetic one. Say you are given 2, 4, 8, 16, and 32, and are told to identify whether the sequence is arithmetic or geometric. We start with the first value, 2, and it becomes 4. That could be plus 2. However, when we add 2 to 4, we do not get 8. So that is not the common difference. All right, then if it isn't, then what is a common difference? Well, truth is, there is no common difference. There is a common ratio. In other words, 2 multiplied 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 multiplied by 2 is 16, and so on. So the common ratio is 2. This is supported by the geometric formula an equals a1 multiplied by r to the power of n take away 1. Therefore, this is a geometric sequence. Let's confirm that using the formula. Now we are aware that a1 is 2, a2 is 4, a3 is 8. So we know that 8, using the formula 8, equals a1, which is 2, multiplied by the ratio. Let's say we don't know what the ratio is, to the power of 3, because this is the third value, take away 1. If we do the algebra, 8 divided by 2, 2 divided by 2 over 2, that will yield 4 equals r to the power of 2. Now taking the square root of both of them, the square root of 4 equals the square root of r squared, right, so those cancel each other. The square root of 4 is therefore 2. This is a common ratio. Therefore, we have confirmed that this sequence is indeed a geometric one. Let's try more practice questions. What about negative 3 over 2, negative 3, negative 9 over 2, and negative 6? Alright, as we know, we must first look for a common difference. Let's try to see a common difference between the second value and the first. So on the calculator, to avoid any mistake, we can plug negative 3, take away negative 3 over 2. That will yield negative 3 over 2. Let's try to confirm that with the other values. So let's use the third value and find the difference between the third value and the second. So we will plug on the calculator negative 9 over 2, take away negative 3. It is important to use the brackets to avoid any mistake. That will also yield negative 3 over 2. Therefore, this is indeed the common difference. We will confirm that by using the arithmetic formula. So the arithmetic formula is an equals a1 plus n take away 1 multiplied by d. That is the arithmetic formula. Now a1 is negative 3 over 2. a3 is negative 9 over 2. Let's plug that into the calculator. So negative 9 over 2 is equal to the first value, which is negative 3 over 2, plus 3 take away 1 multiplied by the difference. Let's say we are solving for the difference. And if we do the algebra behind this, negative 9 over 2 plus 3 over 2 equals 2d. Negative 9 over 2 plus 3 over 2. That's negative 3 equals 2d, which is negative 3 over 2 equals d. We have found and confirmed the common difference and the fact that this is indeed an arithmetic sequence. Let's try another. "18, 36, 72, and 144. Now, we can look for a common difference by finding the difference between the values. So, if we try 36 take away 18, that would be 18. 72 take away 36, that is 36. So obviously from the start, there is no common difference. Let's try to find the common ratio. So by just using the formula. So we are suspecting that this is a geometric sequence, meaning it should be supported by this formula. All right, a1, the first value, is 18. a2 is 36. All right then. No, made a mistake. 36 equals 18 multiplied by r, we don't know the common ratio, to the power of 2 take away 1. All right then, let's do the algebra. 36 over 18 equals 18 divided by 18 multiplied by r to the power of 1. So this obviously cancels. 36 divided by 18 is 2 equals r to the power of 1, which is just r. Therefore, the common ratio is 2. So now you know how to identify an arithmetic and a geometric sequence. Now using this same sequence, we are told to find the sum of the first 15 values. And we have established, for one, that the common ratio is 2, and that this is indeed a geometric one. But how are we to find the sum of the first 15 values? There is a formula associated with that, and it is Sn equals A1, 1 take away r to the power of n, over 1 take away r. Right, so we actually already have all of those information. We have A1, which is 18. We have r, which is 2, and n is 15. So let's go ahead and plug that in. 18, nope, mistake. Right, 18 multiplied by 1 take away 2 to the power of 15 over 1 take away 2. So 18 multiplied by 1 take away 2 to the power of 15 over 1 take away 2, and that would be 589,806. That is the sum of the first 15 values. Let's try another one. Let's take the very first sequence we had at the beginning of the video. And find the sum of the first 20 values. Now, the formula for finding the sum values for the arithmetic sequence is not the same as the formula for finding the sum values of the geometric one. There is a different formula, and that is Sn equals n over 2 multiplied by a1 plus an. Since we need the sum of the first 20 values, we actually need to find the value of a20. We don't have that here, so we need to use the formula of the arithmetic sequence for us to find the 20th value. Recall that the common difference is -2. So we can find the 20th value. A20 equals 100 plus 20 take away 1 multiplied by -2. So if you plug that to the calculator, that is 62. So now we can actually find the sum of the first 20 values, considering we found A20. So S20 equals 20 over 2 multiplied by 100 plus A20, which is 62, and that would be 20 over 2 multiplied by 100 plus 62. That is 1,000 and 620.